We're continuing on with our Chapter 5 questions in our review of 5.4 through 5.7. I'm Lillian Lapilli.
And I'm Tasha Thakahatchee.
We're here to help you today. Tasha, take it away with 5.4 Shield Volcano.
Well, let's talk about shield volcanoes. Shield volcanoes are built of many successive lava flows of low viscosity basaltic lava.
Basaltic lava.
Typically, they emerge from oceanic crust and lack significant amounts of pyroclastic debris. Lava tubes help transport lava far from the main vent, resulting in very gentle shield-like profiles. Most shield volcanoes are associated with hotspot volcanism. And the volcanoes of Kilauea, Mauna Loa, and Mauna Kea in Hawaii, aloha, are classic examples of the low, wide form.
The next is the 5.5 Cinder Cones. Cinder cones are steep-sided structures composed mainly of pyroclastic debris and typically have a basaltic composition. Lava flows are not a significant part of a cinder cone, but lava flows sometimes emerge from the bases of the cinder cones.
Emergent.
Cinder cones are small compared to the other major kinds of volcanoes, reflecting the fact that they form quickly as single eruptive events. Because they are unconsolidated, cinder cones don't stand up well to weathering and erosion.
They're very sensitive to weather.
And what would happen if you had a time machine, Tasha? If you had a time machine, what would happen there?
If you had a time machine and were going to move 4 million years into the future, would a shield volcano or a cylinder volcano make a more reliable landmark still around after that time? I feel like it's pretty obvious they just told us.
That's right.
That the cinder cone would not be around.
That's exactly right, Tasha.
I feel like that's a fairly easy question to answer.
I think you're right.
The context of the page.
Yeah.
Composite
Kind of like
volcanoes.
Madonna's cinders didn't last that long, did they? No.
Composite volcanoes are called composite because they consist of both pyroclastic material and lava flows. They typically erupt silica-rich lavas that cool to produce an andesite or rhyolite. Am I saying that right?
You sure are, Tasha.
Your poor classmates.
Rhyolite.
They are much larger than cinder cones and form multiple eruptions over millions of years.
Lucky volcanoes.
Am I right? Because the andesitic or rhyolitic lava erupted from composite volcanoes, it's more viscous than basaltic lava. It piles up to a steeper angle than it does the lava from shield volcanoes over time. A composite volcano's combination of lava and cinders produces a towering volcano with a classic Hershey's Kiss shape. Mount Rainier and other volcanoes of the Cascade Range in the northwest United States are good examples of composite volcanoes, as are the other volcanoes in the Pacific Ocean's Ring of Fire.
That's right, Tasha. 5.7 is the Volcanic Hazards.
Tell us about it, Lillian.
Well, the greatest volcanic hazard to human life is the pyroclastic flow, or
Get
the
out of the
Nui
way!
Ardente. That's right. This dense mix of hot gas and pyroclastic fragments races downhill at great speeds, like a snow avalanche.
Can't
except
nobody outrun that.
super duper hot. A pyroclastic flow can travel many miles from its source volcano, following the contours of the landscape. Because pyroclastic flows are hot, their deposits frequently weld together into a solid rock called welded tuff. Get out of my tuff.
Welded tuff.
That's right. Pyroclastic flows incinerate everything in their path. That's right. Lahars, I kind of like saying that.
Lahar.
Like magma, one of my favorite words in this whole class.
Mr. Fahar.
That's right.
Lahar.
Lahars are volcanic mud flows. These rapidly moving slurries of ash and debris suspended in water can occur even when a volcano isn't actively erupting. And they can overwhelm people or villages in their path. I'd be overwhelmed.
I've been overwhelmed by hot ash.
Volcanic ash in the atmosphere can be a risk to air travel if it's sucked into airplane engines.
Like that one that nobody can pronounce in Iceland.
That's exactly right. Volcanoes at sea level can generate tsunamis when they erupt or when their flanks collapse into the ocean.
My flanks!
Finally, volcanoes that spew large amounts of gas, such as sulfur dioxide,
I know a few of those.
can cause human respiratory problems. If these gases reach the stratosphere, that screen out a portion of incoming solar radiation and can trigger short-term cooling at Earth's surface. Who wants their cooling at the surface? Nobody wants that.
No, we like it hot.
That's right. That's how we like it. Well, that's been 5.4 through 5.7. Come back for the next one.
Thanks, Lillian. I'm
Thanks,
sure they
Tasha.
will.